Yes. As per requested, we have started one more paper. Alright, so the first 10 question will be discussed this week. Likewise, the 10 question 8 session. And as I already informed you, Mahdi, okay, try to do this assignment question, send me the answer, I'll correct it. You all on sending that, right? So that is also what it's not a past paper question, it's a model papers and my questions, right? You better to try, it should be some kind of the experience and the practice of some questions. So let's we move on. So I thought to prepare right this week, inshallah, I will upload at least three videos regarding what the MCQ, the selection of the MCQ. If you take one MCQ, okay, if you take a 1 year, there might be definitely one or two question is belong to the particular topic. So likewise, I will select one topic and we will discuss the set of the questions. Right, so this is what we'll upload it every week. Okay, so I will send that link that is also belongs to the MCQs because we have to discuss the MCQ is the main part. Hopefully I can understand you all can do the structure part comparable to forward the MCQ, so we will do MCQ. So let's we do. This is what just first 10 question. It won't take that much time, and you're already familiar with those questions. Let me start the question. The first question is. Give me a second. Yes. Consider the following statement 1 and 2. Right? According to the statement, the two scientists who proposed the theory is given by statement 1 and 2. So this is what is very easiest question, the question from the unit 1. Yes. So you have to go through those theories. The first theory is the energy absorbed or released by atom is quantized. The quantum and quantization about whom? Who is the person? Explore about this. Do you have any idea? Yes. The word called
Max Planck.
quantum. Max Planck is the man who discovered about the quantization. So what is mean by quantum? Any idea? Quantize. What is the quantize? The quantum is very important, right? He said the energy is discontinuous one. Can see that is what a particular packets of the energy. Why they made as a packet? They have a fixed amount of the energy. That's why the Max Planck said quantum of the energy, right? Okay, so you can omit by looking. The first statement is for what? According to the Max Planck. So it's not answer 1, not answer 4, not answer 5, either 2 or 3, right? Okay, so let's move on. The second statement. Small particles under appropriate conditions show wave properties. Who is the person to talk about the dual nature? So indirectly, he is telling about the dual nature. What is the dual nature of the particles? Yes. What is the dual nature of the particles? Yes, ma'am. Yes, the dual nature of the particles. The particle can act as a stream like a, right? and it able to act as what the wheel, right? According to that, the dual nature simply explained by the person who is that either could be Louis D. Brockley or Ernest Rutherford. Definitely, you know Ernest Rutherford is the man who explained about the whole fault experiment as a particle, right? Okay. So definitely the Louis D. Brockley is the man who explained about the dual nature of the particle. In your chapter, it's clearly given, right? As you see in these two theories, quickly you can say that is the Max Planck and the Louis D. Broglie. But as per your answer scheme, there is another answer is given for the statement number 1, right? The energy absorbed or released by atom is quantized. It can be either Max Planck or Niels Bohr. So definitely it's directly said by the Max Planck. The answer is correct, but either they have thought inside behalf of the student side, right? Yes, the Niels Bohr, he said what he said. Do you know about anything the Niels Bohr theory? So the Niels Bohr, he is the person. Wait, I just yeah, yes. He is the person. He said the electrons are moved in an angular momentum. So for this angular momentum, they have the fixed energy. So indirectly, the Niels Bohr phrases, it's a key word of the quantum. For that sake, they select answer number 4 also, but actually the answer is number 2. Clear? Okay. Let's move on to the next question. The maximum number of electrons of an atom are associated with principal quantum number n is equals to 3. Yes. Any answer, Mahadev? So what is the principal quantum number? What is mean by the principal quantum number? When you speak of the principal quantum number, right, the quantum numbers are very important. Earlier, the scientists and philosophers said very undivisible particle is atom. Then they discovered the atom as divisible very minute particle, that is electron, proton, neutron. Then later they said, yes, the electron has a work. When you take an atom, there is an angular momentum. But according to that, if you take one particular set of atoms, there is a way how the atom can be expressed. It could be what? Yes, according yes. According to the quantum number, you can define what is the number of shell is present in your atom. What is the shape of the suborbital orbital? How many electrons that each orbital can hold? And how the electrons appears in each suborbital. So this is what the quantum numbers are. We already studied here in this, and inshallah I will upload the one set of the video regarding the quantum number and below that. So next video will be discuss the set of identifiers. Question belongs to the quantum number and definitely. Okay, this is very easiest question. The maximum number of principal quantum number n is equals to 3. So n means what? The number of shell present in an atom. That means the particular atom is having particular atom having 1, 2, 3 shells. We are talking about the number of shells. So this atom having the 3 shells. So when you want to find the highest number of electrons which can be present in your atom, what should be the answer?
What, madam?
What should be the answer? The maximum number of the electrons can be present in this atom where the n is equals to 3. N is what principal quantum number, L is what the azimuthal quantum number. When you speak about the azimuthal quantum number, what he says, the azimuthal quantum number, shape of the orbitals. Right? So L can be defined, right? L is equals to 0 to n minus 1, right? So according to that, so you will have 0 to 3 minus 1. That means 0, 1, 2 is your L. So according to that, you can define the shape of the L. If it is 0, L is equals to 0, that is S orbital. If it is L is equals to 1, it's P orbital. If it is L is equals to 2, that is P. If it is L is equals to 3, that is F orbital. According to that, you know the S orbital maximum number of electrons can be there. That is P orbital, the maximum number is, and D orbital, the maximum number is 10. So altogether 18 electrons. 18 electrons. So what I said here, there is no answer for 18 electrons, but this is the answer. So you have to be very careful. They ask number of electron pairs. That means 18 electrons are there. So to find as a pair, you have to divide by 2. So electron pair is 9. Your answer is number 5. Did you understand, Ma?
Yes, madam.
Okay. So let's redo the next question. Give me a second. I will join. Okay, go through this question. I will join. Okay, find the answer. Yeah. To do this question, right? Sorry. Okay, so this is what the number of stable resonance structure that can be drawn for the oxalate ion. So the oxalate ion is clearly given. This is how your structure should be there. So that means what you able to draw and see how many resonance structure can be present. So this is very easiest question, right? So first you have to know how to draw the Lewis structure, right? So when you take this oxalate ion, C2O4 2 minus. So we should be able to draw the Lewis structure. The carbon is what? 4 electrons into 2. Oxygen 6 electron into 4. 8 electrons. 6 into 4 is a 24 electron. You have the 2 minus means extra 2 electrons. So altogether it should be 34 electrons. Therefore you are able to draw the structure as carbon, carbon, oxygen, oxygen. First deduct the bonding pair. 2, 4, 6, 8, 10. 1, 2, 3, 4, 5. So 5 into 10. So 10 electrons should be deducted. So again 24 electrons. No need. Not. Okay. 24 electrons should be shared. So this is what. The first thing is you have to give the lone pairs for highest electron negative atom. So that means you have the oxygen here. You have to give the 6 into 4. Yes, 24 is complete. Now let's check. Yes, all are octet rule, oxygen, but carbon is missing. To gain the octet rule, just we have to move the. And if you check what valency electron also here 1 is 6s or 2 minus 6s. But here you can have the 2 minus, therefore due to this charge separation we have to move. Ultimately you will end up the result is, I will draw here, the carbon, carbon having with double bond oxygen. Again a double bond oxygen. Check here now. Carbon can have 4. 1, 2, 3, 4. Yes, 1, 2, 3, 4. Valence electron is correct. Octet rule also correct. Check these oxygen. Yes, the valence electron. 2, 4, 6. Yes. Here this oxygen 2, 4, 6. Octet rule 2, 4, 6, 8. Yes, these both are right. And check this. What about your valence electron? Octet rule first. 2, 4, 6, 8. Yes, this is also 2, 4, 6, 8. Both are octet rule is correct. But your valence electron 2, 4, 7, 1 is 6 is therefore minus. And here also having an excess. So ultimately we have found the Lewis structure. So without knowing this, you can directly write if you're familiar with this Lewis structure of the oxalate ion. So let's do.
I did do this.
so sorry for the inconvenience. Right, okay, so let's redraw the resonance structure. So you will have the possible resonance structure. Carbon, carbon. You had oxygen, another oxygen. The Lewis structure also one stable resonance structure. So you can assume the first Lewis structure as a resonance structure. The moment of the lone pair and cleavage of the bonding pair. That should be the next one. Carbon, single bond. This is 1, 2, 3, 4, 5, 6. And this is the heavy one. And this is 1, 2, 3, 4, 5, 6 minus. And this is 1. So you can see here again minus. This is a 1. Right. Okay. And can have here by using this series of this. Okay. You can do carbon, carbon, single bond. And not this. This one. Okay. And use the oil for the okay. So again this is what this is the okay, right? So 1, 2, 3, and you can use the resonated structure also here. So if you use this one, there is no other possibilities the moment of this. Now you can use the resonated structure, the moment of the lone pair and the cleavage of the body. Ultimately, you will end up with oxygen minus this is also double bond cleavage of the. So altogether, the maximum resonance structure can be drawn by using the oxide ion is 4. That means your answer number 3 is 1. Are you clear? Okay.
Madam, second and third are same, no, madam?
Yeah. This is your second. Oh, sorry. You can use another color. Yes. Why second and third? This is carbon 1, carbon 2. Earlier you had what? This carbon. Single oxygen. This is what? Carbon 1. How can be these two are same? That is the difference. Can you see clearly?
Oh, yes, madam.
Fine, clear? Okay, so you are able to draw and see, and the oxalate ion, the carbonate ion, those are very simple stuff we have studied in usual way. So no need to find the structure of the Lewis. Commonly you quickly can draw and just find the answer. What is the maximum possible answer? Right? Okay, so let's move on to the next question. Okay, What is the IUPAC name of following program? So this part we will do. Until now we never discussed this IUPAC. Are you clear? You know about the IUPAC? Definitely one MCQ you will get, and that should be very easy as well. So you have to write. Yes? Okay. Can you say what could be the answer? Sorry. Yes. We have studied, okay, hopefully you might, okay, alkene, alkyne, alkene. In my class, I have started with these things, okay, right? So alkene, alkyne, hydrocarbons, and we have the separate method is the IUPAC of the hydrocarbon, IUPAC of the hydrocarbon, the IUPAC having what the functional group, different functional groups, and the next thing is more than one functional group. So you know guys, this is what, okay, hydrocarbons is a kind of the initiation how to write the IUPAC. Having the functional group, you have to understand how to name. But the more than one functional group is the definite question that you will get in your examination. So that's the thing. If you have more than one functional group, the first highest priority, you might have that abbreviation, right? If you need, I will share the cute is there. I will share for you all. Okay. The highest priority atom will get the one name, right? If you have more than one functional group, right? That is the main carbon chain name, right? The lowest priority one will get the substituent. This is how you have to perform the question. So look at this carbon, right? You have all are CH, that is the hydrocarbon. This is what your common organic compound. You have three different functional groups. Can you see? One is NH2. Another one is the ketone, CO group, carbonate. Another one is the hydroxide. According to this, by keeping this one, you can justify which is having the highest priority. The highest priority atom is ketone group carbonate. Why I said ketone? The carbon containing this area. Okay, I will show you in another color. Simply you can see, okay, this is combined with this also, and this is another thing. This is like CRR group, so that is what, right? So according to that, your ketone, which is getting the first name, so what should be the end of the name? So by using that, you quickly can define the answer. So I said the highest priority is the name given for your main carbon chain. So your main carbon chain name will be end with what? The ketone name. So what is the ketone name? Your chain will end up with on. This is the tabulation. You should be able to, if I start the IUPAC not in a one-day session. If you have any complication, I will send the set of the tools that I have. Just go through that one and try the examples and everything. If you need the explanation regarding the IUPAC, I'll try to make it. Right. Okay, so that is what on. Not one, we are calling as on, right? Okay, we'll put a hyphen on. So let's check. This is amine. Okay, I will use another color. This is amine, not this answer. Okay, not answer one. You can omit answer one. Check here. Pentane, not a hydrocarbon. On can be the answer. Again another on. This is also. This is all for OH group alcohol. So you have to select answer from 3, 4. This is how. Again and again, I'm just directing you all. The first thing is, please try to omit the wrong answer. By keeping the correct answer, then you can justify the answer. Right? So the closest answer, that means the correct answer, can be either 3 or 4. So now you can find the answers. Okay, give me a second. Okay. According to that, let's say clear this thing. Yes. So we said not 1, not 2, not 5. Okay, repeat. And we said the ketone is the main carbon chain. So your numbering should be started from the right to left. Why? Your highest priority functional group should get the lowest number of the carbon atom. So 1, 2, 3, 4, 4, 5. You have 5 carbon. Definitely that should be what? Pent. Both answer is pent. So that is also we couldn't find. Now check. Let's we write the IUPAC. Always. First you're able to find the carbon chain. What is your carbon chain? 5. Right? 5 carbon is there. Right. And you have the chain ending with what? On. Why? That is a ketone. That means your carbon hydrocarbon chain names. Hydrocarbon chain names 5, 10, 10, no. So 2, 10, 10, 9. Why there is a 2 pentanol? You can see your carbon and carbon number 2. So you have to mention as 2 pentanol. Yes, both answers are 2 pentanol. Again, you have to write. Definitely, I have to write that. And let's we find your next functional group. One is the NH2, another one is OH. That is very important. You have to mention the situation where the NH2 is substituted. That is the first carbon. So guys, you will have the one. The substituent group could be right as what? Amino. Right? And you have the OH group, that is 5 hydroxide. Right. So now, when you want to write the IUPAC name, there is the order, right? You have to start the name, right? Your end carbon chain should be the 2 pentanol like this, right? That is you know. But how can you write? Which should become first? This is the big question here. 1 amino or 5 hydroxy. So you have to follow what the alphabet order. So according to the alphabetic order, right order, the amine should come first. So let's rewrite 1. And why we are putting the hyphen? Always the number, between the number and letter, you should write a hyphen. That is the amine. Next number, again a hyphen, 5 hydroxy. Right? And next number we know 2 pentanol. 2. Why pentane? All are hydrocarbon, alkane. Pentane. So your answer is number 3. Is it clear, Mahdi? Do we have any idea about the IUPAC law? how to write the naming system, definitely you will get one question in MCQ. Don't lose the marks. This is very easiest chapter. Yes,
Madam, can we draw the structure for the others?
you want to draw the structure for others?
Yes, madam.
Let's see. So, இந்த எக்ஸாம் வேணுங்கிறது மெசேஜில் நம்பரை போட்டுக்கோங்க. Give me a second. இந்த பதியுமா sorry. Okay. Okay, the first one is the 5-hydroxy 2-oxo 1-pentamine. Actually, I said, right, how these names are arrived. Sorry, came, right? Because we are regarding the 3 functional groups are here. So they have checked which one is the highest priority. If you not given the priority for the ketone, if you give the first priority, then only the name is on. Otherwise, if you assume that is as a substituent group, that is we are giving as oxo. That's why the name came as oxo. So structure is pent. Okay, if it is a pentanamine, so it should be 1, 2, 3, 4, 5. They said one amine. Okay, definitely your amine should be attached here. So this is 1, 2, 3, 4, 5. 2-oxo. Sorry. 2-oxo. Okay. 1-pentanamine, 2-oxo, 5-hydroxy. Now can you see? Is it the same one? Same, right? The structures are similar. Only the thing
Same
is,
structure they have changed they have given wrong way.
wrong way means what? You can think in a three manner, different manner. One thing is, I said, right, you have three functional groups. If you assume, right, what are those functional groups? Amine, yes, hydroxide or all group, alcohol group, and you have the ketone group, right? R. So you have three. Which has the priority? Highest priority is what? The ketone group, not others. If you give the priority for this, your end carbon chain will become as amine. If you think like that, if you give the priority for the amine group, your N carbon chain will come like that. Right. If you not giving anything, just you said it that is just a hydrocarbon chain, your carbon will come as a N. If you give on group, definitely what? Your ketone, you will have on. Why this two thing is, they have interchanged the substituent name. According to the IUPAC rule, the substituent name should be written in the alphabetic order. So that's why they have given another two answers. And why this is a all? If you assume, yes. If you assume the OH group, the highest priority, the numbering should be start from this side. Why? What is the reason your highest priority group, functional group should get the lowest possible number? Then your numbering should be start from this side. If you start at this side, this answer is correct. But actual answer is this. Could be either this or this. By writing the alphabetic order, I have checked this is your answer. So this is what. You have similar structure. If you don't know the rules, you will end up with a different answer. The rules are very important to write the IUPAC. Did you understand?
Yes, madam.
This is what. The thing is, you have to know the order of the priority list, right? Always the carboxylic acid is the first one, I group, right? And other thing is, you should know if it is not the priority level. If it is at the priority level, what is the name of the functional group? If it is not used as a second substituent group, how could we name it? And just always, they never give a simple alkane, alkene, alkyne. Here, this is all are saturated carbon. If one of them has the double bond here, the point is you have started the, can't be here, but it should be here. You'll omit the hydrogen one. So the point is you have started the numbering side here, right? This way. Yes, you will end up with this answer is 1 amino 5 hydroxy. Yes, 2 oxo. I will write down. I'll write here. 1 amino 5 hydroxy 5. Okay, 1, 2, 3. Why? This is what the saturated carbon, that's why you may finish as a pentanol or But if it is what the ene group, you have the alkene or alkyne here. What you want to do is your hydrocarbon chain will be changed and you have to mention the position of the double bond location. So that is what the treatment is. And you should definitely mention if it's two oxo. So this is the dependence. Okay, are you clear? Right?
Yes.
Let's move on to the next question. Identify pair of the elements. Sorry, it has the largest difference in the electronegativity. Yes. Can you say the answer? Largest electronegativity.
Three.
Yes. You're getting answer number 3. Why? Any cases, what is the reason that you have given as 3?
A different period.
Different period. But when you speak about the electronegativity, let's say speak about the periodic process. Along the period left to right, yes, the electronegativity is increasing or decreasing? Increasing. Down the period, top to down, the electronegativity decreasing or increasing? That is decreasing. So you should know these things and let's see write this according to the period. Right. Okay. So you know that is what the long period is. Right? No. Okay. That is 1, 2, 3, 4, 5, 6, 7, 8. Okay. So lithium here you have the beryllium here, right? Next beryllium, its boron is here, then carbon is here, right? And also aluminium is there. So aluminium is straight to this. Silicon, next to carbon, right? So keeping like this, let's see speak about here. Sorry, undo this, Ctrl C. Okay, we use another color. Yes, fine. So identify the pair of the elements, the last. We say down the group, electronegativity decreasing. Along the period, electronegativity increasing. So which should have the largest difference means what? One should have the highest, another should be the lowest. Then only you will get the largest difference. Did you understand that phrase? Right?
Yes, sir.
So you can define along the period the electronegativity is increasing and down the period is decreasing. Among this molecule, carbon is the highest. Are you clear about that?
Yes.
Right? Okay, directly we can go to the answer. So your answer should be with a carbon. So you can omit 1, 2, 3, 4. Right? Okay.
And which should be the lowest? You have boron and aluminium. But at least by looking this, can you say which is having the lowest electronegativity?
Aluminium.
What about the beryllium? So without this answer, I'm just talking, right? You said aluminium, right? So the lowest electron negativity which can be shown by what? The beryllium. One. But the down the group is decreasing, that's truth. But directly for this, if you have the aluminium here, you can say the aluminium is the lowest one, but not here. This is what? Along the group is decreasing. If you take this period, yes, aluminium is higher, right? It's increasing order, not like a beryllium. But we have studied the diagonal relationship. Can you all remember the diagonal relationship? Yes, the beryllium can be shown the same properties as like aluminium because of the diagonal relationship, as well as the boron will exhibit the same relationship, same characteristic like your silicon. All right. So as it is for the diagonal relationship, you can say the beryllium, aluminium also able to possess the same amount of the electronegativity like your beryllium. So for that sake, we are selecting the answer aluminium. Are you clear? Yes, Madhi. Is it clear?
Yes, madam.
So you should able to understand. So the periodic trends, that not also very important. They used to ask. That is unit periodic trends, unit 1. Right. Okay, the unit 1 last session. Cues are there, self-learning videos are there, questions are there. Okay, already unit 1 is completed, it's uploaded, and unit 2 is almost, I'm just finishing the Vesper theory and Lewis structure. After that, I will start the intermolecular interaction. After completion of that, we'll move on to the unit 3. So we'll do one by one, as well as I will upload. Most, if you need, just refer the notes. More than that, just go with the papers and the questions. That would be the very easiest. 9:30. You will leave, right? If I could not complete the discussion, right? You can leave. Then I will keep continuation of this quiz 10, and I will upload in your in YouTube channel, right? And I will send you the link. Okay. Next question. Yes. Okay. The electron pair geometry and shape around the nitrogen atom N1, N2 in the H2NNO. Sorry. The molecule skeleton is given. So you have to find the shape and the geometry and the shape. Before you find the shape and the geometry, you better to try to write the Lewis structure and quickly can find the answer easily, right? Let's we draw the structure. This is your skeleton is given, and this is seems to be very easy for us. You have 2 nitrogen. That means what? The nitrogen is 5 electron into 2, 10 electron. Having 1 oxygen, 6 electron. Having 2 hydrogen, 1 electron into 2. So 2, 6, altogether 18 electron, right? Clear? Let's we draw the structure. Nitrogen, nitrogen, oxygen, hydrogen, hydrogen. Right. Okay. So here, first thing is check your bonds. You have 18. You have 18. Yes. 18. So 1, 2, 3, 4. 4 means 4 into 2, 8 electrons. So 18 minus 8, 10 electrons. Now you have to provide the highest lone pairs for the highest electronegativity. 6 gone. Again you have 2. Again you have 4. So altogether 10 electrons I have distributed. Right? And let's check the octet rule and the okay, right. My daughter is angry. Okay, right. 2, 4, 6. Okay, you can check here octet rule. Yeah, oxygen is having the octet rule, nitrogen is having the octet rule, and here 2, 4, 6. The nitrogen, this nitrogen using is octet. One, two, three, four, five. 1, 2, 3, and sorry, you have to go here. Yeah. Just now I noticed. I have given like oxygen. Right. Okay. So you have to move here. Why this is will get the minus charge? If you move like that, you will end up the answer is. Okay, I'll write here. Nitrogen, double bond, oxygen, 2 bond, and this is what hydrogen, and again 2 bond. Sorry. Again double bond. This is the hydrogen, 2 bond. Correct? Yes. Now let's check. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Yes. 1, 2, 3, 4, 5. Valence electron is correct. 1, 2, 3, 4, 5. Yes. This is also. So this is what your Lewis structure. Now quickly can we find the answer? Can you say the answer? This is your N1. Oh yeah. This is the N1. This is the N2. Yes. What is the geometry of the N1? Yes.
Tetrahedral.
So the tetrahedral, yes. So you can omit answer number 2, answer number 3. Right. What is the geometry of the N2? Yes.
Trigonal planar.
So it should be trigonal planar. That means here they have given the angular. So you can omit answer number 4. Now you can have 1 and 5. Yes, that is a tetrahedral trigonal planar. Tetrahedral trigonal planar. What is the shape for the N1? What is the shape?
N2 is angular.
N1. N1 is, what is N1?
Don't know.
Okay, right. You should know that one. When you speak about the tetrahedron, it's all bonded, right? Notes are there. Just refer by using the. Okay, I will send the link. Finish completely. Right. If all bonded, right, under the tetrahedral, the shape is tetrahedral. Okay. If one lone pair with 3 bonded, the shape is pyramidal. If we have the 2 lone pair with 2 bonding pair, that is angular. And now can you say what is the shape? 1 lone pair, 1, 2, 3 bonding pair, so that is what the pyramid is. At least if you don't know this one, you can go for this N2, you know. 2 bonding pair, 1 lone pair. What should be the answer?
Angular.
So we have to select angular. There is no angular answer. Again, they have given the trigonal answer. So this should be the answer. So you have to guess the answer and can go for one. But you have to know these shapes. Well, you don't know? You know, right? You used to do these Lewis structure questions. Forgot? Okay,
I
and
did.
I have done the separate presentation with videos. Inshallah, within this week I will upload that part with so many examples, different structure under the different shape of under the tetrahedral geometry, right? So if you go through it, it will be really easy for you, right? So we have found the answer. If you know the Lewis structure and the shape of the theory, it won't take that much time. Quickly you can complete this question. Let me move on to the next question. Which of the following statement is incorrect regarding this? Okay, actually I have gone through. When you write the resonance structure, is the first answer is correct or wrong? The resonance hybrid of the benzene. The hybridization you can see, right? This is what we are taking as a resonance. Right. Actually, according to your NIE rules, they are telling this is your hybrid resonance hybrid of the benzene. Okay, we keep that. Right. And next, all 6 carbon atoms of benzene are sp2 hybridized. Yes, that is all are sp2 hybridized. Why? Though the benzene, having only 3 double bonds, but it able to show the resonance hybridization. That means you can see the circular motion. That means these all double bond, we localized all bonded. That's why sp2 hybridized. The bond length between the any 2 carbon atom benzene are same value. Yes, these all are carbon, right? C, 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 C. Any 2 carbon, all are same hexagonal, right? All the CCC and the CCH bond angles are same value. So let's redo. This is the actual shape of the benzene, right? Hydrogen, 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 nitrogen, hydrogen. Right. So this is what you can write just like this. So we are not showing the hydrogen. Without showing the hydrogen, you can draw the concentration. Right. They are telling is the bond angles C, C, C. What is the bond angle? 120. Okay, I will use another one. What is your bond angle? That is 120. And the next CCH. What is that? That is also 120. So that statement is correct. All hydrogen atoms lie on the same plane. Yes. Why? This is the planar molecule. The carbons are attached with your same plane sp2 hybridized carbon. Sorry, the hydrogens are attached to the sp2 hybridized carbon. So answer all correct. But you have to find the incorrect answer. According to your theory, NIE syllabus and my knowledge also, we are telling this is your reference of the benzene. But I have checked the answer. They are mentioning when they ask the hybrid, you have to give the resonant hybrid like this. I am not willing to give the answer, but your incorrect answer they have given number 1. The resonance hybrid should be drawn like this. Yeah, But in your notes, NI group, I have referred those groups. They simply and clearly mention this is the resonance hybrid of bin. Maybe the question is wrong. So the earliest one they have depicted, later the hybridization should be written like this. That means still in your book they didn't change the note. Don't know. Two things are there. But I assume, so it's a kind of the template question, right? They are mentioning when you say the hybrid of the benzene, you have to draw like this. But simply, what is the meaning of this hybridization? It can be draw, no, either like this or this. Both answers are correct. But they are telling this is wrong, this is right. So it's not acceptable in my case. So I will give these all statements are correct. We'll see. Okay? Clear, Mahavir?
Yes, madam.
Some conflict, okay? I keep finding the NI book is clearly given like this. I have to find another resources to find this one, okay? Just now I go through. In my book, it is a different way. Past paper they have given like this. The past paper book is they have given like this. That is wrong. The same structure they repeated. But in your paper, exam paper, it's given like this. Same structure repeated, that is wrong. Why? That is not a resonance, right? This bond should be, the position should be changed. Okay, don't be confused. It's better to understand the note. You see, I'll find and let you out know. So the next question. What is the time? Okay, we have 11 minutes. Okay, question. Okay, let's do this question, and we already done the question. Hopefully, you might remember. Okay, here's the color. Okay. The titanium chloride, TiCl4, reacts with the liquid magnesium metal in to give titanium solid, that is a metal, and the magnesium chloride liquid at a high temperature. When 0.95 kilogram of the titanium chloride is made to react with 97.2 gram of the magnesium liquid, the reactant is completely consumed. This is commonly referred to as limiting reactant. We know where the reactant is the completely consumed, that is the limiting reactant, right? And the amount of titanium solid metal formed respectively. What you want to find here is who is the limiting reactor and what is the amount of titanium solid. This is the question. Okay. I will take the next slide to explain this one and keep this question with you. Let me move on. I will turn the question. Okay. Let me move. I will use the next slide to explain this question. Right. So actually, what this said is the titanium chloride. The titanium chloride reacting with your magnesium liquid and giving the answer also they already given. Let's we write the reaction first, and you have to equal balance these equation. The titanium chloride gas reacting with the magnesium solid, okay, which is giving for magnesium liquid, which is giving, they said, okay, they already mentioned this, titanium metal as well as the magnesium. That is the liquid. Let's see balance the equation. Here you have to This is 2. Right. So you have the result. This is your first step. You have to able to write the reaction and balance the equation. Now, according to this statement, they have given metal reactor and the high temperature when 0.95 kilogram. 0.95 kilogram of the titanium chloride reacted with made to reacted with 97.2 gram. This is kilogram, this is gram, right? 97.2 gram of magnesium chloride. And you have to find what? Limiting reagent or limiting reactor, which is completely conceived we are assuming as a limiting reactor, right? It's easy. We have the value and we know the molar value. Okay, molar mass of each value, that is also given in your question. So let's say find the moles of the titanium chloride. Yes, moles is equal to mass divided by molar mass. The mass is given, that is 0.95. You have to convert into the grams into the power. Sorry. Okay, right? So you can able to find the molar mass by given value, right? So that is 190 gram mole minus 1. So your answer is 5 mole. We have to find the limiting reactor and they have given the definition, the totally consumed amount of the reagent will be considered as a limiting reactor. So let's say find the each reactant mole, the moles of magnesium. Mass over molar mass. Mass is given 97.2 gram. 0.2 gram. The magnesium, molar mass of the magnesium is 24.3 gram mole minus 1. Again, your answer is 4 mole. According to this equation, right? According to this equation, the molar ratio between the titanium fluoride and the magnesium 1:3. That means the 2 moles of the magnesium will react with 1 mole of the titanium fluoride. According to this, the reaction given mixture is, if you need to react, the 4 moles of the magnesium needed to complete. Okay, 4 moles of the magnesium needed to complete. The 2 moles of the titanium fluoride. So what is meant by the limiting reagent, which is fully consumed? Here, the 4 moles of the magnesium is consumed, but only the 2 moles of the titanium is consumed. That means you have balance 3 mole is there. That means who is the limiting reactor? Yes, Mahdi, who is the limiting reactor? What is the definition for the? Sorry?
Magnesium.
Yeah, your definition is fully consumed. Yes, according to this equation and the molar ratio, the titanium fluoride is the 1. Okay, 2 mole of the magnesium needed to react it with your 1 mole of the titanium fluoride. According to your the reaction mixture, the availability of this amount of the magnesium and titanium fluoride, the 4 mole of the magnesium will react with the 2 moles of the titanium fluoride. That means you have balance 3, but the magnesium fully consumed here. Therefore, your limiting reactant is magnesium. We found the answer for us. So, okay, you know the answer. That is as a 4 mole. Keep in your mind, right? I'll just raise it.
Madam,
Yes. Say.
why you didn't consider that 5 mole? You considered the 4 mole no, of magnesium.
Yes, what is the 5 mole? This is the titanium fluoride, right? If you take, okay, what? You asked us question. Yes. If you take titanium fluoride 5 means your magnesium should be reacted what? 10 mole. If the 10 mole is available here, according to your availability, you have to know. What is the limiting reactant? It should be fully consumed, right? So I have taken which is full able to consume. If you take the ratio is however 1:2. If you take the full 5 mole here the magnesium should be 10 mole. To proceed this reaction, the molar ratio is very important. Did you understand? Why I
Okay,
took this is as a 4 mole, if it is a fully consumed the 4 mole, this is balancing, it doesn't matter. But you should need someone to perform the question. Here you have 5, 4. What is the ratio here? More than 5 is missing. So you can't go with that. So what you want to do is you have to find the lowest possible one to complete the reaction. If you take 5, right? Here 5 is completing, but you need 10. But there is only 4. The 6 is not there, 5 is not there. We can't do it. But if you take magnesium as it is a 4, here the 2 only 2 is needed. So the reaction is completing, you can end up with the proper answer, proper observation. The reaction should be done. For that sake, you need the particular amount of the reactants to proceed the products. If you lose to fail to achieve the reactants, how can you carry the reactions to favor the product? That's why. If you take this all 5, we need 10, the 10 is not there. But if you take this 4, right? If you take this 4, yes, this is the ratio 1:2. There is already 5 is there. You can take from there. If balancing is doesn't matter, but not should be less. Did you understand?
Yes, madam.
Okay. So we know the ratio. Let's clear and we'll go back to the answer. Okay, so here the limiting reagents. Not titanium chloride. So answer number 1 is omitted. This is answer number 4 is omitted. Should be 1. Let's redo the amount of the titanium. Simply, according to the limiting reagent, then only you can speak about what? The reaction. So the titanium chloride, that which is reacting with the magnesium. Okay, that is true. It's a liquid. You will end up with the titanium solid, that's magnesium chloride. Right? The reaction is done. Okay, reaction is CH. You have to find the amount of this. Simple manner. Why? Again, take the molar ratio between the magnesium and the titanium. What is the molar ratio between the magnesium and the titanium? 2:1. So, to perform this reaction, you need 4. That means the titanium should be 2. Are you clear? The normal molar ratio is 1:2 between the titanium and magnesium. Why? Here magnesium is a limiting reagent. Why? Give me a second. It's not clear, right?
No, man.
Oh no, okay. That ink is too much. The position should be checked. Okay, so that is what we said. Your magnesium is a limiting reagent here. So that should be fully consumed. According to your answer, you have 4 mole of the magnesium here. Right? So what is the molar ratio between the magnesium and the titanium? 2:1. To complete the 4 mole of the magnesium, we need the 2 moles of the titanium. Are you clear about that?
Yes, madam.
So you have to find in grams. So mole is equals to mass over molar mass. So you have to find the mass. Mass is equals to mole into molar mass. Mole is 2, molar mass is a 48 gram mole minus 1. Your answer is 96 gram mole minus 1. Your answer is 9. Is it clear?
Yes, madam.
Okay, do you have class at 9:44?
Yes, madam. Physics.
Yeah, okay. So I was taking now. So now time is 9:36. Okay, Mabi, I have done question number 8. I will do the other 2 question and we'll complete this video. We'll upload in the YouTube channel and I'll send you the link to it. Right? You can go through that. Okay, you can leave. I will continue the session. Okay? Okay.
madam.
Okay, so you have class, otherwise I will keep you. Okay, good. Okay, just only 2 questions. That is the simple question. You can go through the video, right? I will send the link after uploading today itself. Okay, inshallah. Bye. Assalamu alaikum warahmatullahi wabarakatuh. Take care.
Mashallah.
Okay. So let's continue this question. Now we will move on to the next question. The ideal gas, the equation can be expressed in form of pressure is given the density RT over N. P is the density of the gas, M is the molar mass, unit is given. P is the pressure, Pascal, the temperature is a Kelvin. If the units are all units are given, you have to find what is the unit for density. That's all. Okay, let's see subject the density first. This is your equation. P is equals to rho RT over M. Right. Okay. So rho is equals to Pm over RT. Is it clear? Right. Rho is equals to Pm over RT. Let's we substitute the answer. The pressure that he said Pascal, but here all are meter values. So you have to give them Newton meter minus into. The molar mass, gram mole minus R2, R is joule mole minus 1, Kelvin minus 1 into temperature is okay. The Kelvin will cut off. The mole will cut off. You will end up with Newton meter minus 2 divided by 2. Again, the answer is not there. So you have to convert. You know, the joule is equal to Newton meter. So just go with that. Newton meter minus 2, which is divided by Newton meter. Newton will cut off. This will come up. Your answer. Oh, I missed the gram. Sorry. So your answer is gram meter minus. So this will come up. You will end up the answer. Okay, this is just a subject thing you have done in your physics. Right. Let's move on to the next question. The final question of this session is the decreasing order of the conductivity of living aqueous solution, including water, is. You have to give the conductivity of the water. Sorry, conductivity of the each solution. Right. And the concentration also given here. Let's find the answer. Okay, so the decreasing order. So, what is mean by the conductivity? That is the first question. Right here. Okay, conductivity. What is mean by conductivity? The conductivity of solution you can be defined as the conductance of the unit volume of a solution. We are talking about what? Conductance of unit volume of solution. That is mean by the conductivity. So let's find, therefore, your conductance is here directly convenient for the conductivity. The conductivity depends on what? The number of ions. The number of ions present in the solution. So you can define these ions. Here you have the KCl, acetic acid, HA, and the water. So now I'm going to speak about those ions separately. The first thing is, let's speak about the KCl. KCl is able to fully ionize. That means it is able to completely undergo the ionization. That means like K plus and Cl minus. So the number of ions in the solution present in the solution should be high for the KCl compared to acetic acid and the water. So when you have the two concentration of the KCl. One is the 0.01 m, another one is the 0.1 m. So this is what the highest concentration. Your highest concentration will have the highest number of ions. Right? Therefore, your answer, the KCl should be the increased one, the initial one, and your 0.01 should be the second one. So according to that, they have started the water molecule will give. This is what 0.01 is a wrong, and this should be the answer. And again, so quickly you found the answer, but before that, we have to speak about the notes behind of this. Why the acetic acid is the less compared to the HCl? Yes, your acetic acid is the weak acid which is the partially dissociated. So concentration of the acetic acid, though it is a 0.1, is the 0.1. The ions present in the solution can be low compared to the KCl. Why? The KCl is the fully ionized. You can see only the ion. But when you take the solution of the acetic acid, you can have the molecule as well as the ions. The probability is high. So comparable to the number of the ions is less than to the KCl. That's why your acetic acid is the second one. So again, this is 1, this is 2, this is 2. And your water ionization could be negligible. That means, which is mean it's a lowest conductivity. Your answer number 4 is correct. If you know the a simple theory behind of the conductivity, you can simply give the answers. So according to that, we are telling how you can define the conductivity. Yes, the number of your conductors present in your unit role. So the conductivity, the number of ions present in your unit role, that means the conductivity. So higher the concentration, the conductivity, the number of ions will be increased, the conductivity will increase. So according to that, your KCl is the fully ionized one. So you can have the highest number of ions here. So when you compare the concentration of what? 0.1 and 0.01. Yes, the 0.1 the highest concentration, therefore 0.01 will have the lowest concentration. According to that, we said the conductivity of 0.1 NaCl is higher than the 0.01 NaCl. And why we talk about the acetic acid? Acetic acid is a weak acid which is not weak. Okay, it's fully, it's partially ionized. The partially ionized, when you take the solution, you might have the molecule of that as well as with ion. So comparatively, when you talk about the KCl, the HCl, the acetic acid is the lowest ion per percent. So that means it's 100. And we can neglect the ionization of the water molecule if it has a molecule that it is having the lowest conductivity. So that is the number 4 is the answer, the decreasing order of the conductivity of the solution. Thank you guys. I have completed the first 10 of the quiz question. Inshallah, next week we will set up for the next 10 question and discuss some more. See you. Bye bye. Assalamu alaikum warahmatullahi wabarakatuh. Take care guys.